Good afternoon, everybody. Welcome back to another live stream. I got a little bit of a tickle in my throat, so I'm really hoping like a cold's not coming on. But hopefully my voice will carry throughout the stream. So anyway, so today we're going to be talking about MCP, or the Model Context Protocol, and how it's gained a lot of popularity in the last year and what it's intended for. We'll code one up. We'll demonstrate how to debug one, et cetera, et cetera. So if you follow me on LinkedIn, you probably did see a post that I posted earlier this week about MCP, noting that I'm not wild about it. And I do want to touch on that, but I want to take first an objective stance at what MCP is. So we'll reserve those comments around like why I'm not wild about MCPs toward the end of the stream. By the way, I am taking questions on LinkedIn or YouTube, so if you have any questions, feel free to pop them in the chat. There's about a 20-second latency, just be aware of that. So anyway, so what is MCP? Or let's take a step back actually to understand why MCP was created in the first place. So as you're likely aware, MCP is really designed for the interaction with large language models or language models in general. And language models like ChatGPT, Anthropic, etc. These are models that are trained on public data found on the internet at a snapshot in time. So if I trained like the original ChatGPT, I believe it was trained on data up to September 2021. So if I asked it any information about events after September 2021, it would not have the context and thus would hallucinate. And so again, if you're not familiar with what hallucinations are this idea of the model providing a very confident sounding response, but it being ultimately incorrect. So the classic example that I used back when ChatGPT first came out was again, so this was trained on data up to September 2021. So and ChatGPT was launched in November 2022, and Queen Elizabeth had passed away in between that time frame in September 2022. So if you were to go and ask ChatGPT, when did Queen Elizabeth pass away, it would say she's not passed away, she's still alive. And that's because it was only trained on the data up to that point. So that's just one example in which these models can, if they don't have the right information, they're going to give you back bad information as well. And you can imagine that the same holds true largely for companies with their own private data and private information. So these are naturally, this is a set of information that these models were not trained against, because this would not have been public sort of information that like OpenAI or Anthropic could have gone out to the internet to get. So there have been these many different kinds of notions of, well, how do we provide context to the large language model so that we can reduce the risk of hallucinations? And so one of these is MCP. But the thing I should note about this is MCP. So I believe it launched like late last year, like late November or early December last year, and they're not the first to this game. There have actually been many other implementations of trying to provide context to models in one form or another. If you've been watching my streams for a while, you've probably seen some of the streams on LangChain and how LangChain provided what they were calling I don't know if they called it tools originally. I think they call it integrations now. Basically, the same idea is you within code you can bake in one of these tools or bake in one of these integrations. You can get some extra information that perhaps the large language model was not originally trained against, to be able to provide that extra context to the large language model in order to produce a actually accurate response. So, okay, so again, fast forward to December 2024 or whenever MCP came out. So this is an open source framework that was originally developed or first started by Anthropic themselves. So this is an open source project. This is not necessarily a closed thing that is only being worked on by Anthropic at this point, nor is it anything that you have to exclusively use the Anthropic models for. If you want to use, well, actually, it kind of doesn't matter, because the thing I want to highlight here is with the model context protocol is there's actually no touch to a large language model at all. This is really just the way I like to think about MCPs is like APIs for language models. And hopefully that'll make sense here. We'll get into showing some diagrams and and talk about how MCP works and what MCP is, etc. In fact, let's go ahead and just jump into that. I'm going to go ahead and share my screen. I'm going to go ahead and share the document. So this is the front page documentation for MCP. It talks about the model context protocol here. You'll note here in this highlighted section that it likens the MCP to the USB-C port for AI applications. So again, if you're familiar, if you've been kind of following the technology industry recently, pretty much everybody's going to USB-C right now. Even Apple themselves, partially in part but due to the European Union, they have now converted all of their iPhones and all of their Apple products to being able to charge with USB-C, which is very nice because now I don't have to carry around multiple cords, and I don't have to. Yeah, I don't have to go buying multiple cords. So that's nice. And so the reason that Anthropic stated that they were created MCP is they were, when working on their own Anthropic products, they were finding that they were wanting to provide context to models, but almost seemingly reinventing the wheel every single time they had to do something. So like that, each time they wanted to integrate this model context into whatever they were working on. So they developed this thing called the model context protocol. And so as you can see here, I'm going to go ahead and zoom in on this picture. So here in the center is an MCP. It's actually a server. And that's the one thing that we're going to be touching on quite a bit in this stream, is this idea of MCP as a server. But let's set that aside for now. Let's just look at the left side versus the right side here. So the left side here, I would call these our clients. So these are different things that are going to be needing to make use of contextual information within some sort of AI application. So you can see here it notes examples of like chat interfaces like Claude Desktop. So if you have Claude, unfortunately, I'm not going to be able to demonstrate this in the stream today. I wanted to demonstrate how MCP integrates with Claude Desktop, but I don't know what's going on. I can't open Claude Desktop at all right now. I just upgraded to the latest version of Mac OS. I don't know if that broke it or something. I reinstalled and everything. It's not working, so we're not going to be able to do that today. But no worries. But you can see it also integrates with IDEs, so it knows Claude Code. I am aware that that it can also integrate with GitHub Copilot, which is my personal coding assistant of choice. And then you can see other applications. And then so what the MCP is designed to do is, you would have all these different layers that or data sources that you might want to integrate with. So you could have some sort of Postgres database or a SQLite database that you want to integrate with, or you want to integrate with Git. So like GitHub, for example, they've created their own MCP already, where all you have to do is supply like a GitHub API key kind of thing, and you're kind of good to go. And so, and then you can have the multiple of these like clients integrating with the single MCP, and the MCP can connect out to however many things that you want to here. All right, so that's MCP at a high level. Now let's talk a little bit about MCP being a server here. So it being a server, you actually do have to deploy a compute resource to make use of this. And what I mean by that is when we do typical coding and we want to make reuse of code or whatever, what we do is, like in Python, we'll do something like pip install or uv install a Python library, and we download the static code. So that static code's it's really just text files, like at the end of the day. The code itself is initiated whenever we run our own code. That is not the case with MCP. MCP must be its own standalone compute resource. Now, there is a way to enable it to where it is essentially like a faux server, if you will, where it's essentially you are running something locally and then having it spin up the server at the same time. That's a little bit dicey. So there's a couple of primary ways in which you can manifest an MCP server. In fact, I didn't look. Let's go over to here. We'll get to these primitives here in a bit, but I want to talk about the server thing here. I'm giving myself a breath because I can feel my voice going. I'm really hoping I can hold out throughout the stream. Okay, so that's testing your server. Okay. Well, apparently it's not in here, and well, it's probably in this documentation somewhere, but I don't recall exactly where. Maybe the architecture. Architecture. Okay, yeah, here we go. The transport layer. This is what I wanted to cover. And there's more than just these two transport mechanisms, or well, what's the word? Like subsets of these transport mechanisms. So you can see that we have the two here. So we have stdio. So if you're not familiar with what this is not like a weird shorthand for the word studio. This is actually a common term in the computer science community that stands for standard input output. And if you don't know what standard input output is, let me just open up my terminal over here. So when I open up my terminal, so like whenever this is what we're looking at is basically a version of standard input output. So like I can do a standard in. So like let's say I just wanted to list out the files in my directory, I would just do an ls. So that would be a standard in, and then the standard out here is actually showing me everything that I want to here. So the standard input output, that's what I was referring to, is like if you're a client and you don't necessarily want to spin up a server in and of itself necessarily, like as a dedicated instance of something else, like let's say I want to deploy an MCP to a Raspberry Pi and invoke it from my MacBook, we wouldn't use standard input output for that. We would use the HTTP transport for that. And there's subsets of the HTTP transport. Now, this to me, like to be transparent, is a little bit, it goes a little bit above my head. And I think because this is really like networking kind of stuff, and networking is not necessarily my specialty, and it's not the specialty for many people who would be developing MCPs. This is, well, I'm trying not to get ahead of myself here. But anyway, so what we are going to be coding today is we're going to be coding today just a standard import, one of these stdio transports, and then showing how that we can make use of that within our client code here. Okay. So that is MCP as a server. Excuse me. Let's talk about the primitives of MCP. So if you don't know what a primitive is, a primitive in the context of the computer science community is basically like, I like to think of it like as a basic building block of whatever we're building with. So in MCP, we have 3 different primitives. I thought I saw them in here somewhere, but let me see if I can find those again. Maybe it was an architecture here. I know that I just saw these. Oh, okay, primitives. Okay, so yeah, here's our 3 primitives. We have the 3 primitives here are tools, resources, and prompts. Most people are going to be interested purely in the tools. So as the name implies, tools are the things that you want to call to be able to do some sort of action. Pretty straightforward there. So if you watched the stream last week, whenever we started to introduce agents, and we built an agent in strands, and we created a couple tools associated to that. So like we had a tool, for example, that was telling the current date and time, because large language models being trained at a snapshot in time naturally would not have an inherent understanding of what the current date and time is. So we created a tool in strands and made use of that with our agent. Same idea here. Is that in MCP we would create the tool just as we did in strands. So that's pretty straightforward. This next one here, resources, is a little bit confusing to me, to be transparent. So the way that, because I've had many conversations with ChatGPT trying to understand this, the simplest analogy it will describe this as is, if you think of tools as verbs, you think of resources as nouns. And so you can kind of see here that it would provide, like you could see that it's providing the contextual information about whatever sort of noun that you're working with. So let's say, for example, that I'm building an MCP server with a DuckDB backend. And this is actually something that I tried doing, and we're not going to be doing today's stream because I could not get it to work. And yeah, I'll talk maybe I'll touch on that a little bit more later. But the idea there would be, so like DuckDB, if you're not familiar with it, is it's a newer database kind of format, or not format, but like a newer database kind of database where it is like a nice hybrid between an OLAP and an OLTP kind of database, where OLTP, you think about MySQL, SQLite, Postgres, where that's really designed for fast transactions for like online stores or whatever. And then OLAP is for analytical purposes. So like if you wanted to query data and you wanted to I don't know, you wanted to query every single record, but you only wanted to query one feature of that record. That's where DuckDB or OLAP databases, specifically Excel right there. So it's a marriage of both. It's kind of really easy to work with. I don't know why I'm going into DuckDB. I actually have a coworker who he posts a lot on LinkedIn about DuckDB, and so Matt, if you are watching, you are the inspiration for me checking out DuckDB, and I am really interested in it, but we're not going to be touching DuckDB today. But anyway. So DuckDB in the context of like MCP, so a resource might be the schema of the database. So if you want to just provide, okay, here's what you got in the database. You got XYZ table, and within XYZ table, you have ABC features, and here A feature is this, B feature is this, and C feature is this, etc. And then with the tools, then if a resource is the schema of the database, so then the MCP client would be able to make sense of that schema through something like a resource, and then it could use a tool to actually execute code against that database. So like, let's say I'm provided the schema. I had actually downloaded some public data from, I think, like a snapshot of Netflix at one period in time, where it was just like all of Netflix's shows and movies and a couple of other data fields associated with that. So the schema of that might be, I've got all of the Netflix movies here, column name of movie title, IMDb rating, etc. And then for the resource, the tool, now that I have an understanding of that schema, I can say, okay, now that I understand the table here and what I'm working with, now I can execute a query to say, grab me the IMDb score for the movie, I don't know, The Matrix or whatever else. So that's what the tool would be for. So these two very much go hand in hand here. Now, you do not have to have both of these. And to be honest, like, it's not necessarily clear to me from a very standard Python perspective why you couldn't just bake this same thing right into the code, like of the tool, that is. And we'll get to that hopefully with a little bit of actual tangible code in a little bit to kind of make sense of that. You'll see. Yeah. I'm all over the place right now. So anyway, let's set those aside for now, and let's talk about prompts. So prompts, this is actually pretty straightforward, and I actually kind of like the idea of this. So the idea here is, naturally, you get better responses with different prompt engineering templates. So let's say I'm a developer and I'm building a client that needs to interact with the MCP, but I don't necessarily want to build my own prompt engineering, or like I want to rely on the expert of whoever created the MCP to give me the prompt engineering for that. So that's essentially what prompts is basically a way for the MCP to invoke, or I'm sorry, the client to invoke an MCP to grab the prompt engineering template back. That way, whenever it executes queries against with the tools, the resources, or whatever, it's doing that in an expected kind of way, if that makes any sense. So that's it. Those are our three primitives right there. So just to very quick recap. So we covered MCP as a server. We touched on how you can manifest it as a standard input-output STDIO server or an HTTP server. And in our code, we are going to be using STDIO. And then we talked about the primitive. So with that, let's actually jump into code. And so what we're going to be coding up today, transparently, is not an original example. I tried doing the original example with the DuckDB thing. That didn't pan out. So what we're actually going to be using is an example that I took an MCP course on deeplearning.ai. I definitely recommend that because we're not going to be going as deep in this stream today as that course does. So what this example is it's actually interacting with Archive here. So if you're not familiar with what Archive is an open source project where researchers can upload their research papers to. Very, very popular these days. So anytime a new AI research paper comes out, most likely it is being published out here to Archive. And the nice thing about Archive is it has a Python client. And so it's actually very easy to programmatically interact with Archive here. Yeah, so like, so in the context of like let's say we were building our own custom chat bot, like our own little version of Chat GPT, if you will. Naturally, the models aren't going to have like the latest and greatest papers out here. And so the nice thing about the what we can do here is then, okay, we can build this MCP, and with this MCP, we can simply invoke the MCP to reach out to archive, grab whatever information we need, and then pull it back down. So the way that this example works is we are going to reach out to archive on a topic level. So we're going to give it like you can see all these topics in here. We could say, give me papers on algebraic geometry here. You can see that. And then what it's going to do is it's going to grab however many of those papers that we want, locally download them into a cached kind of file, and then that way we can continually to make use of them. And the only reason I'm doing that is that way if we want to go back and refer to a paper that we've already like retrieved, then we're not doing a second retrieval. We're just making use of the local cache. Okay, so this is going to require a little bit of know-how on interacting with archive. So let's just go ahead and jump into a Jupyter notebook here and then demonstrate how to do that, because it's actually really, really easy to do this. So first things first, you are going to need to be you will need to have the archive Python module installed. So if simply, I think that's just pip install archive. I think. In fact, let me check my PyProject Tumble file. Yeah, it's just archive. So in fact, I don't think I've even synced up my stuff yet. So let me see, source, then activate, UV sync, and let's see. Okay. All right. Well, apparently I'm already good to go. All right. So that worked out. All right. So all we need to do is just do import archive as such. All right. So import archive. All right. Hold on. I'm looking at my notes here. Where is this code at? Where's the code? Give me just a second. I'm looking for the code. I need my glasses. I can see on the other screen just fine, but I can't see on my bottom screen. I don't have this necessarily memorized, but it is relatively easy. Okay, so the first thing that we need to do is we need to instantiate an archive client. So we're just going to say archive client equals archive.client. All right, and then we can simply do a search. So then we just do search equals archive client. Archive. Do we even really need a client? It's acting like it can do it directly. I don't remember. For context, I actually wrote this code like 3 months ago. It's just been a long time getting around to this. So I'm going to say algebraic geometry mix results equals 10. Sure. Sort by the archive sort criterion. I'm going to say relevance, not submitted date. To be transparent, I don't know what this sorting by is. I'm sure it's some sort of proprietary sorting that archive provides. So we'll go ahead and run that here, and then we're going to say paper. Oh, okay. Here's where we actually use the client. So we're going to say papers equals archive client dot results search. And then we are going to just look at the papers here. So, well, how do I iterate through that? So for paper in papers, we're going to say paper ID equals paper dot get short ID. We're going to say paper info equals, we're going to just create a little dictionary object here, title as paper dot title. Title, authors, published, date, published.date, summary, PDF URL. That's probably good enough. I don't really need to do more than that. And then we're just going to say print ID, print. Yeah, I think that's fine. Like, I'm not trying to make this overly complex here. Okay, so you can see here that it successfully reached out and it grabbed these 10 papers. So you could see the names of each of these respective papers here. And I am definitely not an algebraic geometry. And I even spelled it wrong. I wonder if I would get different results if I spelled it right. Let's check it out. Okay, this is starting to look a little bit more like papers that we would expect here. So yeah, it grabbed the papers here appropriately, and that's really more or less it. I mean, well, I guess we do have to extract the information from the paper, but well, I don't know if I'm even gonna worry about that so much. All right, but that's really all we have to do to interact with Archive. So let's go ahead and build the code that would actually represent our MCP server itself. So I'm gonna create a new file in here. I'm gonna call it archive, or no, I'm gonna call it MCP archive server.py. So we're gonna be making use of Python here. Now, one thing you'll notice you should notice instantly, is you'll know that typically speaking in these streams, I like to work out of Jupyter notebooks, and you'll notice here that I'm not using it. We're jumping immediately into Python script. This is because of the server nature of working with MCP servers, it is not necessarily beholden to working all that well within a Jupyter notebook. But there is a tool that can help us with because part of the reason I like Jupyter Notebooks is because you can run just like a very small snippet of code, and then if like I wanted to go back and like make a minor alteration with everything still kind of in memory, then I can still do that by going up to a different cell and just rerunning the cells. So we still can and I know that's probably not best coding practice. Better coding practice would probably be setting breakpoints and stuff within an IDE, but I don't like that. But so what was I gonna say there? I totally lost my train of thought. Anyway, let's just go ahead and start coding things up. So we are going to code this up with a couple different tools. So we're going to have one tool that actually searches the papers. We're going to have another tool that actually, let me actually type this out. So tools to build, let me make this bigger for y'all. We're going to build tool 1 is going to be a thing to actually search the papers. Tool 2 is going to be a thing to extract the information from the papers. A thing to extract the information from the papers. Tool 3, what is tool 3 here? Is getting paper stats. You know what? I'm not even going to do that one today because if I try to do too many tools today, this stream's going to end up being too long. So I'm going to cut that one out for today. I do have I'm looking at some code that's in my repository that's up on my GitHub. So if you want to see the full thing, you're welcome to go up there. So we are going to do a third tool. We're going to say tool 3, a thing to clear out the papers. So recall what I was mentioning, that whenever the way that we're building this is we're actually going to have the MCP download the files into a cache, if you will. It's not like when I say cache, you might be thinking something like Redis or something like that. I'm not even thinking that. I'm thinking about just like the general concept of having a cache. We're just going to save it to a local file. Like that's really all we're talking about. So we need a thing to clear out the local file. And yeah, so that's that. So now let's talk about the resources we're going to build. So resources to build. So recall when we talked about the primitives of MCP, there were these 3. So we have tools, resources, and prompts. So we already covered the tools. Let's cover the resources to build now. So we're going to say resource 1 is going to be checking what available folders there are. And what I mean by that is because we're going to be searching for these archive papers based off of the topic. And so the way that they're going to get saved into this local cache is it's going to be saved by folder or directory by the topic. So we'll have, like, for example, one directory that's algebraic geometry, another file that's, I don't know, Gen AI research, another file that's marine biology. I don't know. Those could be our 3 files. So that's what the resources are going to be checking to see, okay, what do we already have present? So, all right, so that's that. All right, so, and then we are going to have another tool, or I'm sorry, resource 2. Resource 2 is going to be actually getting the papers themselves. So if there are papers present, we're going to look for that. Now, so that covers the tools. Now, let's cover our third primitive, and this is not particularly necessary, but we're gonna put this one in here anyway, and that's going to be the prompt to create. And so we're only going to have one, so it's going to be the prompt, and it's going to be a prompt to find the papers on archive. I know. To be completely honest, this is not necessary, but we're doing it just to demonstrate the three primitives here within MCP. Okay, so the way that we're going to make use of this, I'm going to do a couple imports here. So import JSON from typing, import list dict any, and then I'm going to say import archive. So we already reviewed this. Now here's where we start to introduce some new things here. So in order to build an MCP, the easiest way to do that in Python is making use of the MCP Python library. So within the MCP Python library, to build one of these MCP servers, you have this thing called fast MCP. And I don't know what's going on with a fast MPC under the hood. The name to me kind of implies that this is probably an instance of like a customized instance of fast API essentially under the hood. I'm not 100% sure about that, but I think that's a reasonable guess. All right, so what we're going to do is we're going to say from mcp.server.fastmcp import fast MCP. Okay, and just a quick call out here. And I'm not trying to bag on coding tools at all, because I actually have been using them quite a bit here. You do really have to be careful, especially when you're using newer Python libraries, that you don't get hallucinations like the one I'm pointing at right now. So right now it's trying to do an autofill saying that we're going to import fast MCP server. That's not what this is called. It's just called fast MCP. All right. So now I'm going to set a thing here that I'm going to call paper storage. Storage is a dict, and it's going to be either a string or a dictionary, another nested dictionary of string or any, and we're just going to initialize that here because we're going to be making reference to this. And then we're going to build a couple of helper functions here, and these helper functions are going to be used throughout the tools and stuff that we're going to be building to perform certain functions. So the first one we're going to build here is get all paper IDs. So this is going to output a list, helper so that's not we're going to keep that docstring because that docstring is okay. So we're going to say all IDs equals blank for topic papers in paper storage.values. I think that's correct. All IDs dot extend paper IDs, and then we're going to return all. We want to turn a list. Well, we want to get, so we want a list of this, but we want a unique set of the IDs. So like if there's a paper that's showing up multiple times for whatever reason, we don't want to necessarily surface that. So the way that we're going to do that, we're going to say we want a list of the set of all IDs. And again, if you're not familiar with what a set is in Python, a set is you basically, if you give it like a list of like 50 values, and let's say they're all fruits, like, and it's like apple, orange, grape, banana, whatever. A set is going to take that list in and say, we just want the unique values here. So it's only, so even if you have like apple like show up like 4 or 5 times, it's only going to capture the one instance of that. So that's what set does. And then we can transform that set back to a list by simply wrapping it a list again. So that's that. All right, so now let's create another function here, another helper function called get topics list, and it's going to output a list of strings. And then is that correct? Yeah, that is correct. Okay, so in fact, let me go ahead and kind of put helper functions, kind of helping to delineate what's going on here. All right, good enough. All right, so that's our helper functions. So now let's go ahead and one of the first things that we're going to need to do, hold on just a second, let me look at my code here if I want to actually put this here. Oh, okay, I think that's putting here. So one of the things that we need to do is we need to initialize MCP server initialization. And simply put, all we have to do here is we need to say MCP equals fast MCP, and then we can give our MCP a name. We're just going to call it archive. Okay, Does not matter what that string name is. Oh, did I spell it that wrong? All right, I'll put the I there. So that's all we need to do to instantiate this. Now, the remainder of this code for building the server itself is actually relatively easy and straightforward. And again, if you followed along with last week's stream with strands, this is going to look very familiar to you, because basically all we're going to be doing is we're going to be writing a number of Python functions and then simply decorating those Python functions with a decorator from MCP. So let's go ahead and start building out our tools then. So we're going to say MCP, why did it do that? Didn't mean to do that. Initialization. Okay. All right. So helper functions. We're going to call this our MCP tools. MCP tools. All right. So our first tool, as we were talking about, so we need to build a thing to actually search the papers. So you can see here, we need to just add a decorator. So that's really the only thing fancy in terms of MCP. The rest of the code that we're going to be writing here is just essentially more or less a standard Python function. We're going to say is dev search papers, and then we are going to say a topic is a string, max results is going to be an int, and we're going to set a default value of 5. But that's user configurable, of course. All right, so we're going to say a list of a string. All right, so now we do, again, so this is going to be similar to strands and the other agentic frameworks, where the docstring of the function is very important, because that is how the language model knows what this function is doing. And so we need to say what the function is doing, what are its inputs, and what is it returning back. So it's going to say search. So what is it doing? It's searching for papers on archive based on a topic and storing their information locally. Okay, so our inputs are going to be, if I can type right. All right, our inputs are going to be our topic, and this is going to be a string, or str, and the topic to search for. That good enough. All right, and then we're going to take in max results. The max number of results to return, default is 5. That's okay. All right, so what it's going to return, it's going to return a list of the paper IDs that were found and stored. All right, that's good enough. All right, so now we can actually start writing our code. So we're going to say setting the archive client. So we're going to say archive client equals archive.client. And then we're going to say searching. Let me make this a little bit smaller, that way you can continue to see the code as we're writing it here. All right, so searching for the most relevant articles matching the query topic. All right, so what we need to do here is we're going to say search equals archive.search. We're going to say query is the topic, max results is max results. Yes, yes, yes. We already saw this. This is the stuff, basically this exact same code that we wrote very quickly here in this Jupyter notebook over here, just replicating that essentially here. Extracting the results. So we're going to say papers equals this. Okay. Now we're going to capture those paper ID, or we're going to capture all the information associated with the paper. So we're going to create an object here called paper IDs equals an empty list, and now we're going to iterate through our papers. So for paper and papers, paper ID equals paper.get short ID. Syntax error there. All right, paper IDs dot append to paper ID. Paper info equals. So this is kind of the same thing that we were doing before. Paper.title. That's probably all good enough. Like, that's not exactly how I've written out my code, but I'm just gonna copy and paste this, because I really don't feel, I do want to match exactly what I did, just in case there's some other weird error. So yeah, we're just gonna grab the title, the authors, the summary, the PDF URL, and the publish date, and then we're gonna say papers storage dot is it dot? No, topic key paper ID equals paper info. So again, just passing in our paper storage. Why is that highlighting kind of weird? Did I need to set a global variable or something? Papers storage. equals papers.info. And then return paper IDs. Why is it doing that? Did I name it weird up here? Yeah, I meant to put an S up here. Sorry about that. It probably didn't matter too much, but yeah, there we go. Topic key. What is topic key? Where did topic key come from? Oh, I forgot to extract the topic key. So the topic key is creating a topic key for the in-memory storage. Oops, forgot to put my comment there. All right, so topic key, we're just extracting that. So if not topic key and paper storage, then we're gonna just create a new little thing here. All right, so that is that. All right, now, do I have any syntax errors? Okay, so that is our first tool here. Boom, very simple and straightforward. Okay, so that is first querying the papers. All right, next up, what's our next tool? Next tool is building the thing to actually extract out the information from the papers. So we're gonna say def extract info. We're going to pass in our paper ID as a string. And we are going to return out another string. All right, so we're going to say search for information about a specific paper across all stored topics. Okay, so we're going to say our inputs are going to be our paper ID. All right, so that's good enough there. And then returns a string, and that is going to be a summary of the papers information. Okay. There we go. All right, so that's the doc string. So we're going to say searching through all topics in memory. For topic key papers info. Oh wait, maybe, you know what? I've been saying something kind of incorrectly. I've been saying that we're going to be storing these papers locally into a file. That was the case for the original example, but I forgot I refactored this to just all be in memory. So I misstated there. All the papers are just being held within memory, and they only last for the duration. If you actually take the deeplearning.ai course, I do believe they do store them locally. But now that I'm recalling, the reason I did that is because when I was testing out this MCP with Claude Desktop, there was some sort of hiccup there where, like, because I was trying to save them into a local file, it was having a hard time being able to reference those. So I was like, all right, screw this. We're just going to put it all in memory. So we're actually just keeping everything in memory. That makes a lot more sense now, because I was thinking, because I'm reading my code here, and it's like, well, where are we actually loading these? Like, yeah, we're setting this thing up, but if I'm already interacting with this, I'm surely I got to instantiate this from somewhere. But okay, this makes a lot more sense now. All right, so for topic key, papers info in papers storage items, we're going to say if paper ID in papers info, paper equals papers info. You ever say a word so many times in a row that it just starts to sound weird? That's paper for me right now. Paper. I'm an idiot. All right, so return F. I'm just gonna copy and paste this here because it's kind of a messy little string here that I got in here. So we're gonna return this if it's found, assuming it's found. All right, so that's what we're returning, and then look like. This is one thing. This is another problem that I have with GitHub Copilot is I can't tell sometimes when it's actually added code or when it's just suggesting code. I kind of wish there was a way to. I wish there was a way that it was smarter to know when I want to use it or not. And there might be a setting in there. I don't know. Yeah. Ooh, I didn't see that. Okay. Sorry. Got distracted by something else there. All right. So if it's not there, so we're gonna say if there's no saved information related to paper ID. Okay. All right, fine. Fine. I will take out my extra E GitHub Copilot. All right, what syntax error did I introduce now? It's not it's not tabbed correctly. There we go. All right. So that's tool number 2, extracting the info. Tool number 3, again, clearing out all the papers. All right. So what we're going to do there is, again, mcp.tool def clear papers. We want to clear all the papers, so we're not going to be concerned with just a single one. And we're going to say clear all papers from memory storage. Okay. Inputs are going to be none because we don't have to input anything, and our returns are going to be yeah. Is that am I okay with that? I'm okay with that. Okay. So simply put, all we need to do is we need to do papers storage. Oh, well, I forgot I did this. So what we're actually going to do is we're going to say papers count. This will make sense here in a second. Length of papers for papers in paper storage dot values, and then we're going to say, oops, we're going to say topics count equals the length of the paper storage, and then we're going to do a paper storage dot clear. And the reason that we got these two values was simply so that well, GitHub Copilot's reading my mind here. We're going to just return a statement that says we cleared this many papers across this many topics, and that's really it. Okay, so that's the tools. We have now set up our MCP tools. So to be clear, like actually writing the code for an MCP server itself, not that bad. It's the client that's bad. Okay, somebody's telling me my mic is too low. I think my mic is, let me try to crank that up a little bit. I try to get, trying not to get, I've had issues when I crank up the volume on the, on my side where it, I just start to, what am I trying to say here? The microphone gets all crackly and stuff. I'm not a production expert, so apologies for that. You might just need to crank up the volume on your end. So I tried turning it up some, but I'm scared of turning it up too much because then it gets fiddly. All right. Anyway. All right. So those are our tools. All right. Tools done. All right. So let me add some extra spacing here because I like me some white space. All right. So white space. All right. So we've initialized the server. We've created the tools. Now let's go ahead and create the resources. The resources are a little bit more nebulous to me in how they work. So we'll go ahead and say MCP resources. So recall that we have our two resources up here that we're going to build. We're going to be building, checking what available folders there are, or topic folders there are, and then resource 2 is going to be actually getting the papers themselves. I think that's correct. Maybe I misunderstood what I wrote there. Okay, so let's go ahead and build our first resource out. Now here, let's go. This is where things get a little bit strange, at least in my opinion, just because I'm kind of, I don't know what this is getting at. So naturally we have a decorator here, but what they like to do actually is they like to have these, this format of these URIs that I'm writing right here. And I just don't understand this. I don't this code all works and stuff. I just don't necessarily understand what the benefit of structuring the URI like this is. So just being transparent, this code will work. I'm not really sure why this piece in particular works. So we're going to say def get available folders string. All right, so list all available topic folders stored in memory. This resource provides a simple list of all the available topic folders. Okay. So simply put, we're going to say getting all the topics from memory folders equals list paper storage.keys as such. Then we're gonna starting off the content string. So we're gonna be just appending to the string more and more. So we're gonna say content equals, and we're gonna return it kind of as a markdown kind of thing. So available topics, and then we're gonna do like 2 new line things. All right, and then we're gonna say if folders. So if it exists, for folder and folders, content equal, we're gonna get the topic name or a readable topic. We're gonna say readable topic equals folder dot replace. Yeah, so we're gonna just because it's got underscores in it, so we're gonna replace the underscores with spaces just to kind of keep things simple, and then we're gonna append that onto the content as do I want, no, that's not exactly how I have it in here, but we're gonna say key folder. All right, that works. All right, and so we're just gonna keep appending to the string. Now, obviously, if we don't have that, we're just going to have a different response that says content plus no topics found, no topics in memory, use search papers to add some topics. Is that what we called it? Yes, it is. Okay, so yeah, search papers to add some topics. Okay, and then simply put, we return the topic. So we're going to say, I forgot to put our parameters. Inputs are none. Returns markdown formatted list of the available topic folders. All right, so that is resource number 1. All right, now our second resource, let's scroll back up to the top. Second resource is actually getting the papers themselves. So let's go ahead and do that. So we're going to say at MCP.resource papers topic. Okay. This stream's going to end up getting really long. I just realized that because we're still writing the server code, and the server code's not the hard code. It's the client code. All right, so let's do a def get topic papers. All right, so we're going to say topic is a string, and we're going to be returning a string. And then we're going to say, darn it, gets detailed information about papers on a specific topic. All right. Inputs is going to be the topic naturally, and returns. What are we returning here? Yeah, that works. In fact, just for time's sake, I am just going to copy and paste this code because there's nothing fancy here, and I'll walk through it really quick though. Okay, so essentially what this is doing is, again, getting the topic key, searching to see that the topic key is in the paper storage. If there's nothing there, then we just return back this thing that says, no, I couldn't find anything. And then if we could find things, we're just going to keep adding to this content string here, very similarly to the resource above, and return all that. So that's it. So that's that. And all right, so that covers resources and prompts. Resources. Now let's cover our last bit here. And our last bit is going to be setting up the prompt. MCP prompt. And again, just for time's sake, I am going to just copy and paste this here because there's nothing fancy about this at all. I just want to demonstrate what it is, just for covering an all roundabout kind of thing here. All right, so basically we got another function here. Decorator's a little bit different, and we're just doing mcp.prompt this time, where so like the way that the prompt here works is you don't actually just retrieve a static prompt per se. Is you actually, it's kind of like a Python function where you actually give the inputs values, and then we'll return like this full prompt kind of thing here. And again, this is, like, in my opinion, this is probably not necessary because like the language models are probably intelligent enough to know what archive is, and to know like if I want to use like an MCP like the MCP tool here to actually retrieve stuff from archive, it's probably going to know that. So like this is probably redundant and probably not needed. So all right, so that covers that. Now let's just round things out here in our script with the script invocation. So we're going to say script invocation. All right, what we're going to say is if name equals main. So we're going to say MCP dot run. And then we're going to say our transport is going to be stdio for standard input output. If I wanted to do like the other variants of like HTTP or whatever else, it's just as simple as just updating the string here. So that's the MCP server itself. So now let's go ahead and introduce a debugging tool that Anthropic built for MCP called the MCP Inspector. Now, something to be mindful of here, and I don't know that I necessarily touched on this super well. Let me go back to their main page here. All right, so this is the how an MCP kind of manifests. When the client connects to the MCP, it is a persisted connection. And what I mean by that is it's not like a standard API in the sense of, you reach out to the API, you might provide in some security credentials, a client key, an API key, an API key, some sort of other JWT, whatever, and then you interact with an API that way. In the context of MCP, you are constantly connected to the MCP, or the client is constantly connected to the MCP, and that makes it like a little bit challenging in terms of building, the client itself. And I do kind of understand in the context of like using an MCP for GitHub Copilot or Claude Desktop, it makes sense to do that. If you're just a standard developer wanting to interact with an MCP in your own Python script, this can introduce some problems. We'll talk more about those problems later on. But the only reason I mention that context now is basically the MCP Inspector, the debugging tool that we're about to use, is intended to do is it's going to demonstrate how we persist that connection, and then like a couple of other ways in which we can interact with the MCP server. All right, so let us go into our terminal here. So I'm going to go into repos, cd gen AI miscellaneous, MCP archive /stream. All right, because this is the file that we're working in. So there's our server right there. And what we're going to do is, let me actually check here, because I already did the install. I can't remember off the top of my head what you have to install. So you do have to have like npm already installed here, because we're essentially just going to be making use of these commands right here. All right, so the way that we do that is, so I already have npm or npx already installed. To be transparent, I'm not really, because I'm not a web developer, I don't really know npx super well, but all we have to basically do is go over here and say, all right, npx model context protocol /inspector, and then we have to run our command that actually initiates this thing. So I'm going to do uv run mcp archive server.py. All right, so let's go ahead and run that. Now what this is going to do is it's actually going to pop us into a web browser over here where we can actually interact with this in a user interface kind of manner. So the very first thing we need to do is, even though it started up this inspector, we are actually not initialized with the MCP server right now. So that's what this button over here on the left is we need to click this button, and now you can see we are officially connected to the MCP server. Now if we go back over here and we actually look at this, we can actually see that we are persisting our connection here. You can see here that I can't necessarily go typing additional commands because we do have this standard import output kind of manifesting in here, if that makes any sense. So you can even see that up here, new STDI connection request, and then it's got all these whatevers and blah, blah, blah. And let's go back into this. So up at the top here, you can see like a couple of things in which you can kind of see like how like test various things out. So for example, if I go, well, we're already on the resources tab here. So I could click list resources, and it's going to say get available folders. Now I am concerned because that is, we should have had more than one. There should have been two there. mcp.resource paper folders, papers. Okay, so I did something incorrectly here. Little bit of a syntax error. All right. So we're going to say papers, folders, and then we're going to get topic. That should be correct. So I probably do need to, I probably do need to restart this. So let me go ahead and redo this. All right, so let's go ahead. It's probably going to pop us into a new instance over here. So we'll again, click connect here, list our resources, get available folders. Why is it not showing? Oh, interesting. I didn't realize that it had like a different thing for resource versus resource templates. So you can see here, whenever I just click the get available folders, that you can see that we're returning the text off on the right over here that says there's no topics in memory right now, which is correct because naturally we've not done anything yet. So let's say I actually went ahead and ran one of these tools. So let's go ahead and list our tools out here. So now when we click the list tools button, and again, this is just a debugging tool. This is verifying for us our like a bit of a sanity check where we are still so you can see here with this view that yes, it recognizes our tools. Yes, it recognizes our resources, and we can even do things such as directly like actually making use of these within the interface here. So like, let's say if I wanted to do algebraic geometry, I'm not going to do that one. I'm going to say marine biology because I can't spell right biology. I actually can, but I don't want to spell wrong on camera. All right, so you can see here that I ran that. We got a success. Where is the... All right, so that was successful. So if we went ahead and extracted out the information based on the paper ID, and I don't necessarily have paper. Somebody's at my door. Oh, just a delivery guy. All right, so actually let's go back to resources. And now when we click the get available folders, you can see on the right here that we do have available topics here, marine biology. And so if I were to come back in here, do another search or search papers, I'm going to say this time we're interested in generative AI. And then we run the tool again. Then we should be able to see through the resources again here. Let's go ahead and do a refresh here. Yes, we do have generative AI in here now. All right, so that's resources, that's tools, and then there are a couple of other things in here that you can use. I'm not overly familiar with, and then you can even see that you can change if you are running like an HTTP server, then you can change that appropriatally. The last thing I wanted to show you here was just the prompts. So if we go ahead and list the prompts out, so we do have our generate search prompt. And so again, if you recall, we for the prompt, you actually accept parameters in, and then it will return back the prompt back appropriately with the parameters already filled out. So if I say enter topic, I'm going to say marine biology, it doesn't matter what it is. Enter number of papers, we're going to say 10, and then we do the get prompt. Then you can see here that we do get our prompt back appropriately. All right. So that is the MCP Inspector. And you can see here that we are, through the MCP Inspector, we are able to connect to the MCP appropriately, and we're not getting any errors or anything. So, yeah. Let us go ahead and build the client code. Now, the client code is unfortunately not as simple and straightforward as the client code. Or I'm sorry, the server code. And the reason for this is it comes back to this idea of having to maintain the persisted connection. And so because you have to maintain the persisted connection, we're actually going to have to make use of Python asynchronously. So if you're not familiar with asynchronicity, is that a word, asynchronicity? The issue here is that typically speaking, whenever you run a Python code, you run line by line in a sequential kind of order. Well, with asynchronous, you can actually have like multiple threads going on at the same time. And so that's important in the context of here with the MCP, because you have to maintain that persistent connection. So we're going to have to basically use the asynchronicity of Python to maintain that persistent connection while also doing all of our code. And you'll see this is going to get kind of kludgy really fast. So let's go ahead and start to build out our client. So I'm going to go back in here. I'm going to create a new file. I'm going to say MCP archive client.py. All right, collapse that down. All right, let me pull up my notes down here. Client. All right, and then we're just gonna like we're not gonna do anything necessarily fancy here. We're just gonna write a bunch of short little things that demonstrate each of our pieces here. In fact, to be transparent, I just had GitHub Copilot write this all for me, but we'll write it all out by hand. That way we can go ahead and understand what's going on under the hood. Now, the very first thing that we need to do is we need to do a couple imports. So from MCP, import client session, stdio, server parameters, and types. Then we're going to say from mcp.client.stdio, import the standard import output client, stdio client. And then we are going to just import async IO from Python, async IO, and then we're going to import JSON. And then we're going to have everything run through this single function here. And I'm only doing that because through a single function because like I don't want to go fussing around with anything else. So I'm going to call this async def test MCP server interactions. All right. So I'm going to just put pass here for now. But I want to just actually just show the invocation script here. So that with the invocations here, so if we go if name equals main, then what we need to do is, because this is again an asynchronous kind of concern here, we're going to do async io.run, and then we're going to pass in the function itself here. So that is kind of straightforward. Now it starts to get a little bit more messy, and this can be your results are very much going to vary here. So the very first thing that we need to do is, again, recall that we are using the standard import output kind of thing here, because we don't necessarily want to stand up a fully fledged server for this particular MCP. We want to make use of it as we would make use of local code. All right, so we're going to say, oh wait, we need to go back and alter this function here. All right, first thing up, we need to set up our server params. Server params equals stdio server parameters. Now this is gonna start to get a little bit messy. So for me personally, in order to invoke Python correctly, I had to actually put the full darned file path for actually running Python. And what I mean by that is I'm gonna say command equals users.dkhenley -documents -repositories -genai miss /venv/bin/python. Ugly. But like, if I didn't do that, it just didn't want to recognize Python appropriately, and yeah, we'll get into my gripes about MCP in a little bit, but I think you're probably starting to see some of them. All right, so args equals we're just gonna say because we're in the same working directory here, we're gonna just say MCP archive server.py, and then we're gonna have env equals none. All right, so that is setting up our parameters. Now we need to set up this other thing within here, again, to help with the asynchronous kind of connection here. This is going to, again, start to get really messy. Async with stdio client server params as read write. All right, and then we're going to say async with client session read write as, not client, we want to do it as session. Then we're going to say await session dot initialize. So this is more or less the equivalent of when we were back over here and we clicked the let's go ahead and do the disconnect here. When we click this connect button, that's what this is all setting up here. I know, probably if your eyes are bugging out of your head, I wouldn't surprise you, because this is, again, what I was talking about. When it comes to writing the client code for an MCP server, it starts to get really weird and strange very quickly. And actually, the rest of this code, I think I'm just going to copy and paste in here, but we'll walk through it because there's just a lot of code here, and we're already over an hour. And yeah, so I'm just going to copy and paste this code here. Basically what we're doing is a bunch of print statements. But as you can see here, let's just walk through a couple of these. So the very first thing that we need to do is so we're going to be constantly interacting with this session object over here, and then we can run standard functions to be able to do whatever we need. So we have this first one is just going to be listing the available capabilities. So we can say listing out prompts, listing out the resources, listing out the tools, and then we're just going to print all those. The next one, we're actually going to get the paper stat. So we're going to say well, actually, this is a tool that I actually omitted, so we're going to remove that. We're going to remove that. So, because I forgot that I did not do that. I don't even. Yeah, so, all right, so the tool 3 here, we're actually searching for the papers. We're demonstrating how to search for the papers. So so the way this works is you can see here with the session, we're invoking the call tool. We are actually passing in the tool name, and then we're passing in the parameters here. So you can see the tool name is going to be the same as the function name. So if you recall here over in our server file, we have this tool over here. We called it search papers. So that, again, it's just matching over here. And then we are passing in the parameters of we want topic of machine learning, and then we want the max results to be 3. And then we're extracting the paper IDs there. And then we're evaluating, I don't know what AST is. Again, I had GitHub Copilot kind of write some of this code for me just to make things easy. So, all right, papers, stats, after sorts. I think I omitted this one as well, so I'm going to go ahead and delete that. Again, there were a couple of things in here that I did that just for time's sake, I just kind of threw out the window. So extracting the paper information. So you can see here, we're just getting the paper information from this kind of stuff. So you can see here, we're again calling the tool. We call the extract information. Recall that we pass in and the ID of the paper to actually make use of that. All right, so that's covering the tools. So let's continue scrolling on down here on how we're going to cover the resources. So again, what I'm trying to illustrate here is a lot of this is interacting with this session object. And if you're not familiar with what await does, so imagine if, let's say you have a single Python file running and it's got 2 threads going on. So let's actually take the asynchronicity out of this for a second. So in a typical Python script or a typical coding script, it's going to run from top to bottom in sequential order, and it's going to wait for the previous line to finish before it executes the next one. So like, for example, if I'm loading up a CSV using pandas, it's going to do, and then I want to list out the top 5 rows. I would do pandas.read CSV as our first line, and then the next line will not start to execute until the previous one's finished, and that works just fine in a Python script without asynchronicity. But then the question becomes well, how do I handle the situation where I might have multiple threads going on here? And so in this case, we actually do have multiple threads going on here because we have the thread that's actually running the Python code itself, and then we have this other thread that's actually managing that connection to the MCP server. And so how does the first script know when to actually, that this other asynchronous kind of thing is going on, is ready to be used? And that's what this await keyword is all about. So, so we're interacting with that, getting the papers there appropriately. Now you can see that we can, so we're printing those out. Well, then we're also reading the resource back in with the machine learning here, and then we are searching for papers on another topic just to kind of demonstrate what things look like if sorry, I was just reading through some of this other code here. Everything here is just kind of demonstrating the interaction with the MCP server, but there's actually interacting with the session itself and calling tools and stuff is not that hard. But again, keep in mind here, we are not baking in anything else within this script. There is no LLM. There's no LangChain doing whatever. There's no strands, or there's no crew AI. Imagine trying to do all that with also trying to manage this. This becomes very cumbersome in my opinion. I don't like the idea that I have to set all this up. So let's go ahead and run this script. I think that covers everything. I think I took out that one, so I'm going to remove that. So let's go ahead and run this. Python, all right, ls, Python MCP archive. stream cd MCP archive cd stream clear Python MCP archive client.py. So now it's going to go ahead and run, and it went ahead and ran everything successfully. It looks like there was a warning here of some sort, but it looks like everything else ran kind of successfully. Yeah, so you can even see here. Now these numbers are not going to make sense because I deleted some stuff out, so you can see here. Where's number 2? Well, I deleted that out. But everything did run here appropriately. And that's that. So that covers everything in terms of the coding. Now let's wrap things up here and talking about why I'm not wild about MCP error. There's actually a couple reasons. I wrote them down. Let me go and refer to them. Number 1 here is it is being a server itself. So again, MCPs manifest as servers, and so then therefore you have to consider them as servers, and then so that's just adding extra overhead that seems kind of unnecessary in my opinion. And this next one kind of goes hand in hand with it being a server itself, and that is the security element here. Now, I'm not a security expert, but I do know that this is kind of concerning. Like, so if you're just now joining, when I started off the stream, I gave an example of an MCP where you might want to interact with like a database like a DuckDB database. Now the question is where does the authentication take place, or where should the authentication take place? Because you don't want necessarily anybody just connecting out to the DuckDB constantly. Like, so do you want authentication on your MCP? Do you want it on? Well, let's say you want it on both. Maybe you want an authentication on the DuckDB server itself, because maybe you're interacting with DuckDB natively without MCP, and you still want to be able to interact with that. How do I pass through those credentials through an MCP server to appropriately make use of that? Now, I do believe that is being addressed, but that is still kind of concerning to me. And then, so we talked about being a server itself. So now we have to be mindful of like this compute resource out there. So we have to deploy something in a compute-like fashion in order to make use of this. Whereas if this was like a Python library, all we'd have to do is import the Python code and boom, be done. And actually, so that is something I kind of want to liken here. Is so you can see here how we built these tools, and we just decorated it with like the MCP.tool here. Now let me go. So if you watched last week's stream, we covered agents a little bit, and we covered strands in particular. So if we go into the strands folder here, like, so here, like the syntax here is basically the exact same. But in order for, like, let's say I was building like if I'm a client application and I'm trying to build in my tools, do I want to interact with an MCP, or would I rather import something like this? I would personally rather import something like this 10 times out of 10, because it's just way easier. Like trying to, and that was going to be my last point here. Writing all this code to get the client connected appropriately is just a headache. Like it's not necessarily intuitive, especially if you don't understand server interactions and such. I had to do a lot of upskilling and such myself just to be able to understand everything that I'm talking about today. And even then, I don't think that I'm talking about things 100% clear. I understand standard import output, but if I had to build an MCP server that was using like streamable HTTP or something like that, I would have to have another server friend come help me out with that to help me understand what I was doing there, or else because I would not want to risk screwing that up for them, and then trying to authenticate that correctly. So, and that's the other thing. It's just a headache. That's the bottom line, in my opinion, about MCPs. And then another thing to be mindful of here is I think I am going to do a stream on this at one point. AWS recently came out with a service called AWS Bedrock Agent Core. And Bedrock Agent Core is very interesting. It's basically a bring your own agent kind of service, although I think you can actually make use of it without an agent. I want to test that out. And it provides a lift in a number of ways. It adds AI observability, things like that. But one of the things that it actually offers is this thing called Gateway. And what Gateway is basically a standardized way of allowing the respective agents to be able to interact with the respective tools. And the thing with that is that you don't necessarily have to have an MCP to build one of those gateway tools. You can integrate an MCP, But AWS has actually demonstrated a couple of ways in which you could actually use Lambda functions or even standard APIs in a very similar fashion like you would use MCPs, but without having to worry about that. And so in that instance, if I was building an agent using Agent Bedrock Core, I already had like an existing API that I wanted to wrap. I would probably just try to figure out how to integrate that with Gateway and not have to worry about all this business of, oh wow, how the heck do I do this whole client instantiation? Because then I wouldn't have to worry about that. So, and I guess the one thing I need to be extra clear about is I am not saying that there is no room for MCPs. In fact, there are a couple instances in which I can think that you really do need MCPs. And those instances are the coding assistant tools. So like, for example, GitHub Copilot here or Claude Desktop, they do make use of MCPs. And because they are coded in such a way that, like, and I think the hardest part here is, and you saw this, coding the server code itself is not hard. It's the client code that's hard. And whenever you're building an MCP for like GitHub Copilot or Claude Desktop, you don't necessarily need to worry about the client code because that's already being handled. Although I will say that is, even though I can't pull up Claude Desktop right now. If you're just joining the stream, for some reason, I'll even show you. Like when I try to open Claude Desktop right now, and I think it has something to do with the fact that I just upgraded to the latest version of macOS, it just won't open for me right now, and I have no idea why. But behind the scenes, CD library, CD application support. Nope, not accessibility, application support. ls cd Claude. What I want to show here is, okay, so behind the scenes, you have this thing called the Claude Desktop configuration. And so if I cat that out, this is where you actually set up your MCPs. And again, this got, as you can see here, whenever I tried to initialize the command here, this just got really messy. And this was very hard for me to configure. And so originally, I did want the demo for today's stream to be a connection to a DuckDB. I could not get it to work with Claude Desktop. Like I tried my darndest and I just couldn't do it. So all that to say is, you know, there is definitely room for MCPs. Like I don't want to say that there's zero case for MCPs. It's just that, like, when I look at this, like the server code here and then the client code here versus like what I had to do for strands here to make use of it within an agent. So this is instantiating the tool. Now, how do I, to make use of it? Well, let's just go back to the client here. Like if I actually wanted to make use of a similar code here in MCP, I would have to get all this set up appropriately and cross my fingers and hope that nothing breaks here. Or I could do this, where all I do is just say, okay, here's your tool, boom. So I would much rather do this. Like this to me is far easier than trying to fiddle around with an MCP client, building an MCP client script like this. So, all right, today's stream went longer than I expected, but we are done. So I hope you all can understand a little bit more about MCPs and develop an appreciation of when to use them versus when you might not want to use them. We will get back to our streams on agents. I'm not sure exactly when. I got a vacation coming up in 9 days, so might be a little bit before we get back to that. So hope you all enjoyed this one. I am going to get out of here, and I hope you all have a good weekend. See you next one.